So in the previous session, we talked mainly about objects. What is an object? So object is nothing but it's just a internal class. An object has been created. So just like we create a class, in a similar fashion we create a object. We just use the keyword object. We just use the keyword object ABC, and we create multiple members here. Since there will be only one copy, since we can have only one object by the name ABC, so there will be only a single copy of the members. So hence it could be used as static. Hence this could be used as a static, but we know that to achieve static, we have to again make use of companion class and companion object. So we have to define one more class, ABC, only ABC, and define this as private member. Only then we can make a member as a static of this class. Now this becomes static member here. So that's what we saw in the previous session, and with the example of a secret agent. Now there is one more use case of a static, sorry, not the static, companion class and companion object. One more use case, again, we also saw that every object, every main function will be returned inside a object. Always the main will be returned inside object. Now one more use case is companion class, companion object, and apply method is used to define a factory design pattern. So let's see how it looks like. I shall give a simple example how it looks like. Now based on this itself, we will be looking into the case class. So there is a lot of buzz around the internet on case class. Now let's see what is that case class. First, to understand case class, we need to understand the way a factory design pattern is achieved with the help of companion class, companion object, and apply method. Now first we have to see what is a companion class here. Sorry, my mistake. What is a factory design pattern? Let's say we have a just to give an example, we have a Sony factory. In this factory they manufacture mobile. In this factory they manufacture TV and game box, something like this. in the same factory, in the Sony factory, they are coming up with a different product. They are manufacturing a product totally which has its own functionality. Mobile has its own functionality. They are able to come up with, they are also manufacturing a TV which has its own functionality, and they are also manufacturing a game box which also has its own functionality. Every product they are manufacturing, they are having a totally different functionality here. So we can, factory design pattern is also similar to that. So there can be a class. So from this class we get an object 1. So from this class we can create one more object. Now this object has its own functionality. So it's not similar to an object created as object 2. I mean, if we create one more object 2, both are not same. They have their own functionality. Similarly, we are creating one more object 3. It also has its own functionality. So that's what we mean by factory design pattern here. So let's say we have a multiplier class. We have a multiplier class, and from this multiplier class we are creating an object called doubler. From this multiplier class we are creating an object called tripler. And from this again multiplier class we are creating one more object called, let's call it as a quadrupler. Something like this. Now the functionality of the doubler is to double the value. The functionality of this object is to triple the value. The functionality of this object is to multiply the value by 4 times. So if you see here, from the same class we are able to get different kind of an object. From the same class we are getting totally different object. That's what we call as a factory design pattern. Now how can we achieve this? So you should achieve in such a way that the syntax should look very simple. So you should create a object something like this: val doubler is equal to multiplier of 2. So this is just simple, right? Just we are saying multiplier of 2 equal to doubler. Similarly, tripler is equal to I have to say just multiplier of 3. I should not say something like this. I should not say new multiplier object. Then I should not say val uh, in this fashion. I should not say val doubler is equal to new multiplier, and I should not say doubler dot init. Just initialize it to 2 so that we can double the value. This should not happen. So it should look something in this fashion. The syntax should be more intuitive and more readable, saying that yes, we are creating a doubler object. Yes, we are creating a multiplier of 3 object. Similarly, it should be in this fashion. And this object, when we get this object, we have to just use doubler of 2. I mean, whenever I say doubler of 10, it should give me the value as 20. Similarly, when I say, once I create an object, after that when I say tripler of 3, it should give me the value as, let's to get the confusion out, if I say tripler of 5, it should give me the result as 50. I should not say something like this. So after getting the doubler, I should not say like doubler dot product. There should not be something product method, and if I say this, then it should not give a, this should not be the syntax. This kind of a syntax we should avoid. This kind of a syntax we should avoid. We should avoid such syntax. Instead, we should try to give this syntax. We should clearly have in this fashion: val doubler is equal to multiplier of 2, and then we just say val result is equal to doubler of phi something. So this result should be value as 10. So I think this looks like a more of a intuitively it gives us a impression like a factory kind of initialization has been done here. So such kind of an initialization can be done with the help of companion class, with the help of companion object, companion class, and the apply method. So let's see how it looks like. Let's see how it looks like. So what I will do is let's initially write it in some other fashion. So let's say we have defined a class. We have defined a class called multiply, and we have defined an object also, a multiplier. We have both the class and object with the same name, and both are defined in the same file. Hence, multiplier is a companion class, as well as we have a companion class and we have a companion object. Now the way we have defined here is my mistake. I'm writing in a wrong fashion here. Purposefully I'm writing in a wrong fashion. I mean, let's say we have a init method here which is used to initialize an object of this class. Simple init method which will always create an object of this class. An object gets always created. And inside that class we have a product method which computes the product of the given input parameter with the initialized value. So obviously the way we would create an object of this is we would have created val doubler is equal to, we would have used the multiplier object. We directly call the multiplier object because since it's an object dot we call the init method. We don't need to create a new here. The new keyword is not required because multiplier itself is object. So if we use new keyword, then companion class, it will get associated. It will think that the next thing that is coming is a companion, a class. You are specifying the class. So in that case, we need to specify some value here. So we don't want to use the new keyword here. It should look as intuitive as possible. So I will just say multiplier is this object, and multiplier object dot init I will call, and I will pass 2 as the parameter. So as soon as I call this method, internally what it does is it creates an object. So we got a doubler object. Now I want to compute use this doubler object. I want to double the value now. I'll just say val result is equal to doubler dot, doubler is the object of this class. So I can just use the product method of that class and just specify. Now this does not look so intuitive. This does not look so intuitive and does not give us an impression that we are working with the factory class. It does not give an impression. We are using a init method here. We are using a product method here. It doesn't give so much of a intuitiveness. But we are getting a doubler object. It will give the result. The results are fine, but not in a way we think it. It's not so intuitive. Once you read this program, it doesn't give us so a readability. So if I run this program, I should get the result. I should get 2 into 3, 6 I will get. But how can I improve this? How can I, not performance improvement, readability improvement, so that we intuitively we get a impression that we are working with the factory pattern. So what we can do is, instead of init, we can define a apply method here. We can define a apply method. Now we know that apply method is just like any other method we can call in this fashion, or we also know that we need not call the apply method by its name. We can just skip the method name altogether. So now you can see that we are getting an impression of a factory design pattern. Multiplier of 2. Multiplier of 2. So that's the main thing. This is the main thing of the of combining apply method, companion object, and a companion class. You get a method. I mean, you 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 design API such that it looks like a factory initialization. And we can also make this product method also rename it to apply method, so that we need not use we so that we need not call it by name. I can, even though I can write it, I need not specify the name. That's the property of the apply method. That's the property of the apply method. Now as you can see here, now we are getting a much better readability. We are creating a multiplier object by just passing 2 as the parameter. By just passing it, this itself says that it will double the value. In a similar fashion, I can create tripler is equal to multiplier of 3. So it is equal to, I can use tripler of some file. It will triple the value and give the name itself specifies. I am creating a multiplier of 3 object. So that's the use of using companion class, companion object, and apply method. We kind of get as a factory initialization technique. So that's the use of, that's what I was trying to say here as the fourth point. So now keeping this in mind, we'll talk about the case class. What is case class? So I have, there are a lot of buzz, but nothing much is there with respect to case class. Case class is just like any other class. There is no new concept associated with the case class. No new concept at all. It is same as normal class, but only thing is the compiler implements some methods for you. We don't have to explicitly define certain methods. Some things are already implemented by the compiler. That itself they call it as a case class. As you can see, what all things are already implemented by the compiler. The compiler has already implemented the apply method. Where it has defined that apply method, the compiler has defined that apply method inside the object. Meaning the compiler has also created the object. The compiler has also created the object. I mean, this part is already done. So this part is already, sorry, not that part. This part is already done. The compiler defines an apply method. Where it defines inside an object. I mean, this is also this is also already created. Where it is initializing an object, where it gives us a factory kind of a initialization method. That's what it is saying. A factory method for instantiating the class. What else it defines? It defines a copy method. It already defines the equals method. It already defines hash code method, a toString method. If you remember, we also had defined the toString method. ToString method is to display the objects in a human readable form. Otherwise, it will display the object as some hash code, some memory location will be added. And one more thing is that it also defines an unapply method. So these are the methods that are, or these are all the things that are used in the case class. I mean, no new concept. Only thing is, all these things are already defined by the compiler. If we ourselves define all these things, again we are making our class as a case class. That's all.
Pramod,
Yes, Kalyan.
is apply a keyword or a built-in method, or are we overwriting that method?
No, apply is just a normal method. It is not a built-in method. I mean, it's a
So,
we
I
ours
mean, is it mandatory that we need to write always that apply only, or can it be apply 1, apply 2, apply 3 kind of thing?
nothing.
Any?
We always have to, if at all we have to define it as apply only.
And what about the other two, like the init and product you mentioned? Those are also, there are inbuilt methods are there?
No. Those again, none of the methods are inbuilt methods. I mean, we have to define based on our need. We have to define those methods. What kind of functionality we want to achieve, based on that we have to define our method.
So does that mean apply we have written as we have created an instance of multiplier class here? So in one more object, if we create one more apply, if we define one more apply method with a different functionality,
right?
So which one will be used?
I mean, it depends on the object that you are creating of.
So can we have multiple apply methods in a program?
We can have based on input parameters can change. As a result, different overrided apply methods we get.
Okay. Okay.
I mean, it is just like any other method. What I'm trying to say here is, if I define class, something like this. I can have a define add method, just like any other method. This is a simple method. I can create val uh, is equal to, this is one object. So it is just simple method add, which adds 10 to A. In a similar fashion, I mean, we have defined it as add because we want to achieve additional functionality. Just in a similar fashion, apply is also a kind of a method. Just like add is a method, apply is also a method. But we have to figure out what could be the use case of apply method. Now the use case of this add method was to do some addition operation. Similarly, there are different use cases of a apply method. It is achieved used for a factory instantiation. Yeah.
Pramod, can you have apply methods with different parameters in the same
Yes.
class or in
Yes.
object?
Yes. It
So,
is. I mean,
so
it is just like any other method.
okay.
Any other
So
method.
it is. So when we call it, it only checks for the number of parameters and the order of data types, right?
Correct.
So
Correct.
then it will. Okay.
It will only.
So it works like an anonymous method.
You can say that. You can say that.
Okay.
The
So only use is without mentioning the name, we can pass the parameters.
correct. That's the property of the apply method. You need not call it by name. Whenever you are calling
Okay.
that, so you can. That's the property of a method, apply method. So we need to
Okay.
make sure how we can use that property. What
Uh,
would be the best way to use that property?
so
So
it will be used only in the case class and the factory pattern only, or
yeah, as of now, some initialization that we want to do, such kind of a stuff helps us. So you can see that how the list has implemented it. So if you see
right.
here, we have list. So list has made use of that apply method to access its elements. So actually this object, there is a apply method defined inside the list class so that we can access the elements. That's how it has made use of that property.
So this is like kind of uh, the hash code and equals method. So it will be within a um, method in the object itself?
Sorry, I didn't get the question.
Like the Java, we say we have some default methods, right? The equals hash code. So like that applies a method which will be any object will have this method, right? Apply method.
Not any object. I mean, I don't know what all objects will have, but for sure
Okay.
list has it, vector has it. Most of the collection they have already defined a apply method,
Oh, okay.
but not necessary that it will be there everywhere. It is not.
Okay. Okay.
The only thing
So
is,
it is there. Okay. We can also override it, right?
yeah, we can also write our own apply method.
Okay.
I mean, we need,
So unapply method is
yeah.
totally. It's like taking out the element from the collection.
Unapply method
Apply.
I will explain. I will explain.
Okay.
But apply method is
Thanks.
just like any other method. Some class might have already defined it. Some class may not have it. We can also define it. We may not also define that. It all depends on what we want to make use of that apply method. Whether you can write a class without apply method only, without writing an apply method. That is also fine. It is not mandatory that we always need to have a apply method. I was just saying that it is just a method, just like any other method. Only property it has is not to use its name while calling. That's the property it has. So, so, so the list implementation, they have made use of that property to access the elements. In the vector also the same property has been used to access the elements. In the set, they have used, in the set collection, they have used it to check whether an element exists or not. They made use of,
I was in the question like it acts like a get method to get the element by passing the
right,
text.
they have made use of the apply method just like a get method. They have implemented the logic of the get method in the apply method. That's what we can say.
But it has a different usage also
Yeah,
when used in all.
you can make. I mean, we need to think of it. What usages we can use it for? What all usages can be got from that?
Okay. Thanks for me.
Now apply method. So as you can see here, so we can also define a list. So in the list class also they have defined the apply method. Actually, when I say I am creating a collection object with this syntax, what actually internally happens is they have defined an apply method. They have defined an apply method that takes the input parameters and it creates the collection object. So this is also one more use they have made of the apply method to create a object of a collection which takes multiple parameters here, which are the elements of the collection. So this is also one use case of the apply method. We can also write our own apply method here. So based on that, what we have did is we had val nums is equal to list. There inside the list there is one more apply method which takes multiple parameters, variable number of arguments. This apply method takes variable number of arguments, and what it returns, that apply method returns a collection object. Now, based on this, what we can say about the apply method, we can give a definition for an apply method. I mean, with respect to only this example, I can give a definition for this apply method. The reason I'm giving a definition of this apply method is I want to understand unapply method. I want to explain what is unapply method. The main idea is to explain unapply method. To explain unapply method, let's try give a definition for a apply method. I mean, apply method, you can have multiple definition based on its use case. Based on this use case, this particular use case, I shall give a definition for this apply method. What I can say is apply method takes input parameters, or members, whatever we can say, or elements. It takes elements, input elements, or members or parameters, and returns object. This is what we can say about a apply method, but only in this context. I'm saying only with respect to this context. Now what can I say about the unapply method? It is just the reverse of apply method. So apply method takes input parameters, members or elements, and returns an object. The reverse of that is it takes an object and returns members or parameters, or we can say elements. Whatever it's just the reverse of the apply method. And just like you need not use the name of the apply method, in a similar fashion, unapply method name also is not required.
So is it like dissociating the members from the object?
Right. You give an object to that unapply method, it will return all the members of the class. It will extract. We can usually say it as it extracts the members. That's the apply method. Now, what is the use case of having such a method? What is the use case of having such a method? So as we can see here, unapply method, again where it is, the compiler has already defined it is in the object here. So it extracts the instance into a tuple of its fields. So it takes an instance is nothing but it takes an object and returns the members as a tuple. All the members will be returned as a tuple here. So that is used for case class pattern matching. This is where pattern matching is possible with the complex data type. If you remember, we had seen normal pattern matching on an integer, on a double, on a boolean. We saw the pattern matching. Here pattern matching is also possible on the complex data type, and it is because of the unapply method. And that's the reason you will hear a lot of things about case class is nothing but case class is used for pattern matching. So you want to match and extract certain fields you want to check and extract certain fields, that's where the pattern matching is used. That's where the pattern matching is used. So unapply method, it's a bit, I mean, we also can write our own unapply method, but it's very rare that we will write. Most of the time we make use of the already existing unapply method. So let me take an example how it looks like. But these are all the points we need to remember about a case class. Only thing is, some methods are already defined for you. So this kind of a syntax is already, this syntax is already defined for you. Whenever we say case class, I mean, if I say when I say case class multiplier, when I say this, just say case class multiplier. So what the compiler will do is, the compiler will create a class called multiplier. Inside the class, it will define equals method. It will define equals method. It will define toString method. It will define hashcode method. It will define, what else is there? Copy method. It will define, what else is there? Hashcode, toString. And if we see unapply method and apply method, but those two are defined inside the object class, meaning it will also create a object. It will also create object multiplier. And inside that it will define apply method. I mean, the compiler will define an apply method which takes some int and it returns new multiply. And it also defines unapply method. Unapply method, it takes an object of type multiplier and returns a tuple here. So all these things are already defined by the compiler just by saying one line of code. And as usual, we know there will be setter and getter method also. There will be constructor also defined. Because normal class already implements constructor, default constructor. It also has setter and getter methods. And the compiler and the input parameters is also treated as the member of the class. This will be also treated as the, so with just one line of code, we are actually defining all these things. A constructor is being defined, setter and getter method is being defined, equals method, toString method, hashcode method, copy method, a companion object has been created. Inside that, a apply method has been already defined so that we can instantiate use a factory kind of a pattern to instantiate an object, and an unapply method. So we'll see what is the use of unapply method. So that itself is a case class. That's all. Its only thing is we are taking out the burden here of writing unnecessary, like writing so much of a code. We are just writing case class. That's all. So I hope that that case class was mostly clear. So the main thing that we want to say about the case class is this unapply method, due to which we can do pattern matching here. Due to which we can do pattern matching. So let's define a I have a simple case class here, a character case class which has two members. Now what it means here is these are also the member of the class, that we know that, and this is also input parameters of the class. I mean, there is a difference between just to know here. So when I say case class character and I say name as name is string and is the is boolean. So when I say case class here, name and is_Steve, these are members of the class. These are members of the class, and setter and getter method is defined, because it treats them as val name and val is. Whenever we say case class, it treats them as val name and val is Steve, hence they become the member of the class. And since it is a val, we need not specify, the compiler does not define setter method, it only defines a getter method. But when we say class, we just say case, without case we just say this. Without case. We know all the other differences. I mean, there are a lot of, when we use case class, lot of extra functions are already defined. Along with that, I'm saying one more difference with respect to input parameters. When we say in this fashion, name and is Steve, they are members of the class, but no getter and setter method is defined. So when we don't attach a case here, these are all simple parameters. We can only treat them as parameters to constructor. They are not, since there is no getter and setter method, you cannot access this members outside the class. You cannot at all. You can access if you define in this fashion: class character. If I say val, we ourselves specify val here, val name as string, and val is Steve as string.
Pramod, if you don't specify val or where, so what it takes by default?
I mean, by default, I mean, it doesn't matter what it takes as default because you cannot access it at all.
Oh, okay.
You cannot access it at all. It will be internal to the class. I mean, it will be immutable. It will be immutable, but there will be no getter and setter method.
Okay.
Now, when we say val here, there are two things associated with this. When I say val here, it means getter method is created. So that you can access.
In the previous
Yeah.
this one, so the name string is thief boolean. So we can define our own methods, right? Getter methods.
Here,
Or
right? Here.
right. Yeah.
Yes, you can create our own getter methods. We can do that.
And make it public, right? So we can access the members.
Right. We can make that. We can make that. So by default, what I'm trying to say is, by default, what happens is the syntax. I mean, so this also, I mean, if you want to have the getter method and setter method, we have to define val or var.
Right.
So we are getting this by just using case class. When we say case, it is as good as writing in this fashion. That's the difference I wanted to say here. If
Okay, in case class, it takes it as a val only. Sorry, where only, right?
val. When I say case
Val.
class, it is same as this.
Oh, okay, yeah.
When I say case class, it is same as this. As a result, we will have a getter method. So we can access these things. So just I will showcase that once.
We cannot set any value.
I will just define a simple class. It is not a case class. I'm defining a simple class here. I have to create an object in this fashion. Is Steve will say it. Now if you see, I cannot say Joker dot name. I
Right.
cannot access them when I just say in this fashion, because
Right.
there is no getter method defined for them. So it can be treated as, the main idea is to give an impression that you treat them as only constructor parameters. You don't treat them as a member of the class. But it is actually, because we can write our own getter and setter method. Here the compiler does not create a getter and setter method if we define in this fashion. So if I define in this fashion, if I say val here, if I give val or var anything, if I give val or var anything, now the compiler creates a getter method, and we know that the getter method is same as the member name. getter
Yeah.
method. So now I can say joker dot name. So getter method has been already created, hence we are able to access. So just a I mean, they have made it a bit tricky here, unnecessarily these things, but we need to just keep this in mind. If we don't specify any val here, you cannot access those members. If you define anything here as val or var, we can access those members. So when I say case class, I need not, when I say case class, when I say case, it is same as saying here val name and val is. It is same as that. So we know that now I have defined it as a case class. So there are some of the functions are already defined by the compiler now. So I can say val joker is equal to, I need not use the new keyword. I need not use the new keyword because an object has been created and we have already have a factory kind of a instantiation. So we can directly say character of, just like we used to call multiplier of 2, in a similar fashion I can call this. Sorry, I mean to say I need not use the new keyword because the object is already created to initialize a new object. I can just say Joker Batman false. So factory kind of a design pattern is achieved through the apply method and the case case. Now I can use the unapply method. So is there any question there?
Yes, Pramod. So in the previous example which you have given, where which was not a case class, and where the members were not accessible outside of the class.
Right.
So will those members will be accessible within that class?
Yes, yes, it will be. It will be.
So, so if it is accessible and if you want to override the members, so how do we know whether they are by default defined as val or var?
It will be val actually. You cannot modify those things. Default is you cannot modify them.
Okay. Okay. Yeah. Thank you.
So now here we can use a pattern matching. I can say val message is equal to, I can pass that match to the, we know what is a match expression. Specify the expression, then the match keyword, then you have the case. Case I can say character. I can check whether it's a joker. Then bind the second parameter to x and just, so use some string interpolation. Check whether is 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 joker thief. So I just dollar give the value of x. Similarly, I can just say case vector, I can say. I'll return is Batman is dollar. I can use the case class on complex types. Not only we can use a normal integer data type or a boolean data type, we can also use it for complex data type. So this is where the unapply method comes into picture. Internally here the unapply method is defined. Here actually unapply method is defined, which takes, we know that we evaluate this object and we pass into the match expression. Whenever we pass into the match expression, it is passed. Here we are actually calling the unapply method. To that unapply method, the bat object is passed as a parameter, because it takes that object and returns a tuple. So whenever it returns, it binds the return value, whatever is the true or false, to x. Similarly, it returns a y. It returns the. So that's how.
So X and Y is a kind of a placeholder for the values.
Right, it is a value binding. We learnt about value binding in match expression. Any value we pass to the match block, it gets binded to whatever identifier we specify. Here the second parameter of the character, second parameter gets binded to x.
But okay, but it has to match, right? Batman is a character, so
Right,
which has a Batman or false. Then whatever we give in the case class should match. But we are using a value binding.
right. It matches this. What it says that I will match an object if it is a character object and the name should be Batman. Only then the pattern will match.
Okay. It's a partial
It's all
matching, right?
right. It is kind of a extract values. Check and extract. Check whether it is
Yeah, it's
Batman and extract the value of y.
right. But it is not checking all the members, value of the members within that object.
No, it's only checking the first, because we have defined it. We are saying in that fashion. We are saying that the first parameter has to be Batman. Only match it.
Okay.
It will bind the second parameter to y. That's how the pattern matching works.
So if you don't have, if you didn't give the value binding variable, then it will match all the values, right?
Right, right. It will try to match all the values.
Okay. Yeah.
So we can if you see, like I have val, so I will take val user1, take val user2, take val user3, take val user4. So I have 4 users. I have 4 users. So user is nothing but a class object. I mean a tuple. It is a tuple. It is a tuple. So I can make a case class instead of that. I can say case class. I can say user and say name as string. Next we have age, right? Employee, I just said ID as int name as string, age as int, city as string. So we are defining a employee case class. So what this means is there will be created an employee object, internally apply method will be created, unapply method will be created, toString method will be created. All those things will be created whenever we say a case class. So we can say instead of user1, I will say employee1, and I will say so we are creating a employee object. Similarly, user2, instead of user2, I will say employee2. Similarly, instead of employee user3, instead of user3, I'll say employee3 and name it as instead of user4, I will say employee. So we have an employee. I have a employee here. So I can have a collection of these employees. Val is equal to list of employee 1, employee 2, employee 3, and employee. So it has created a collection. It has created a collection of each employee record. We are having a collection of each employee record. So if you see, it is displaying the how an object looks like. Why it is displaying in such a manner? Because toString method is defined. Because the toString method is defined, it is displaying the object in human readable form. Otherwise, it would have displayed in a form of hash code, as you can see earlier. So as you can see earlier, if we don't use a case class, there will be no toString method created. Hence, you can see that it displays the object in this fashion, some hash code, some memory location of where the object is created, which is not so helpful to read this, which is not so helpful. So whenever we create a Joker object here, if you see here Joker object, whenever we created a Joker object, it displayed the data in a human readable form. It is because of the toString method, which is already defined. Now we have a collection of employees. We have a collection of employees. Now I can use these employees in the filter higher order function. So I can say val result is equal to employees dot filter. I can say filter, we know that takes a function and returns some value. It returns true or false. Based on that, the employee will be collected in the destination collection, or it may not be collected in a destination collection. So we can have something like this. So I will define a function get certain employee. some based on some condition, which takes a employee employee class, and I can say I can use a match expression here. I can use a match expression, and I can pass this employee to the match expression, and I can say case. Instead of using lot of if else condition, I can use in this fashion. I don't care about the ID. Second parameter will be binded to name, and I want the third age has to be 24, and I don't care about or I care about the city. So in that case, just return name and city. Similarly, I want one more case. So I don't care about the name. I want the name, and the age should be, let's say, 50. I want only users with age 24 and 50. I want only the users with age 24 and 50.
So what it takes for the underscore?
Underscore means it doesn't care whatever it could be. It doesn't care whatever is the name, ID.
Kind of a wild card?
Yeah, it could be a wild card.
Okay. I'm trying to understand where the underscore in multiple scenarios it is differently.
No, in pattern matching, we know that underscore is used as the default. If nothing matches, underscore is used in the match expression. No, here also it is same. We don't care about what is the value there. It will anyway match there.
Can you use the underscore for other fields also if we don't want to compare?
Yes, we can use. The idea here is to use the underscore is we don't care what will be the ID. We just know that there will be some ID, but we don't care. Let it match to any ID.
Okay. So it checks only the age, which is 24 and 50, and displays the name and city corresponding employees name and city, right?
Name and city, and my mistake. I did a mistake here. I have to rewrite this. I will say true because I cannot use it in the filter hierarchy function. I will say it as false. Again, sorry. I'll rewrite this once again.
Okay, you're going to call this method in the filter.
Yes. Pass that to true. If it is true, case anything else I get, I'll just say false. So as we can see here, this function takes an employee record and returns an object. So we can apply on the filter higher order function. I can apply this on the filter higher order function on the employees. On the employees, I can call filter higher order function and I can pass get. So now we know that we only get the users with age 24 and 25. So in this way we
The
can
not function.
yeah.
The not function will also work, right? Exclamatory.
Filter not.
Not.
I haven't used filter not.
Filter. Filter. No, no. Oh, it is a. There is a function filter not itself.
Yes, yes.
Okay, I thought a filter within the bracket not of get certain employee.
No, you cannot. You cannot pass that because filter takes a function. It
Oh,
does not
okay, okay,
take
okay.
any operator.
Oh,
Not
okay.
it has to treat it as a not symbol. It will treat it as some method. So you cannot pass such method.
Right. Okay, okay, got it.
So we can get the reverse of this. So this way we can make use of the pattern matching in this fashion. We can use it if you want to return only the name and city. If I want to only get the name and the city, so in that case I need to use a map higher order function. Try to use the map. I mean that may be not so intuitive, but this is where we use a match expressions. So this works because all these things work because internally unapply method is defined. We are defining a unapply method. I mean, because we have defined it as a case class, as a result we can use it in the match expression. I mean, we can achieve the shortcuts also here. I can directly use the function literal. This whole function literal I can use. Again, they combine these two things and write the things. So what I'm trying to say here is I have a function defined in this fashion. So we have employees dot filter and I pass this because it returns true or false. For whichever condition it is true, that element will be collected in the destination collection. Now instead of this, I can directly use the function literal. So I can directly use this function literal. So you will see such kind of I can take each record, I can use a function literal. And they achieve some more shortcut here. They completely remove this match also. So both means the same. We can directly use in this fashion also. So this way we can also write. This is same as writing in this fashion. This is same as writing this is same as writing. With this also we should get the same result. We can check that by internally the match expression and the input parameter is combined and showed here. We can also write it in this. Missing parameter type for expanded function, the argument type.
But the previous code has more decoupling.
Right. I mean, more readability is there.
Yeah.
So,
We can change the logic also, the function logic.
yes. I mean, we need not go by this way. I meant to say it takes in this fashion. Just a second. Somewhere I missed a syntax here. Or let's forget this, and it's not required. And this is we can go by these things itself. Either we specify this or we can use a function literal here. We can use a function. So that's the one of the use case of pattern matching. This is one of the use case of pattern matching. So you want to extract something also. You can also use it in
Can we check triads also in the pattern matching?
traits I'm not sure. You need
Yes,
to have traits because traits does not have unapply method. It only works because of the unapply method. Normal class will also not work.
okay.
Normal class.
But we can use triads in the templates, right? We can pass triads to the templates, right?
Templates in the sense.
The type of identifier. So we specify the integer float data type
Right.
as a parameter. So like that, we also define a type as a trait also in templates.
Let me check. I'm not much sure on that. Let me check on that. If you could send me an example, I can check.
Oh.
Not much sure on that. Or we can take it offline. I'm not sure.
Sure.
I do not understand much of a question here, but we can take it offline.
Okay.
So here we can also use the map higher order function. Map higher order function takes each element and we pass each element to the match expression. We pass each element to the match expression and we can say case employee. It could be anything. First, I don't care. Second parameter is name, gets binded to name. Age, I don't care. Third parameter gets binded to city. So now I will just return. I want to check whether it is an employee record and just extract name and city. Match the syntax and return name and city. So it returns only name and the city. Now we are explicitly saying that the second parameter of the employee is name, fourth parameter of the employee class is city. It gets binded to name and city, and we got that name and city, so we can make use of that name and city.
Can't we extract the name and city without the match?
We can. I think that is without the match also we can do that. That is a much more simpler way of doing that. It is just that we use map. We know that each record is an employee object. We just say each record. I mean, each record is an employee object. We just say e dot name, comma e dot
City. Okay.
city.
As a tuple, right? Which returns a tuple.
I'm trying to return. This is much more simpler, but here we get to know that we are trying to match an employee.
Right. Yeah.
But I'm not sure this itself looks much simpler.
Yeah.
Much simpler. It takes, just because we know that each record is an employee object. Map higher order function takes a function which takes each element of a collection. We know that each element of the collection is employee. Employee has a name method and it has a city method.
But here we can use e dot underscore 1 2 3 4, right? That works.
No, no, E is a employee object. E is not a
Yeah,
tuple.
employer.
If E was a tuple, we could have used.
Is E is not a tuple?
E is each element of a collection. E is just an element of a collection. Employees is a collection of.
Okay. So what happens if we try to use the underscore 1 or 2?
No, I mean, E is, you don't have that underscore itself, because E is an object of employee class, so you can only
Okay.
use the methods defined inside that class.
Okay. Only in plain tuple we can use it, but not in objects.
Right. Not in object.
Okay. Makes sense.
So here we can use much more shortcuts here. Underscore dot age, comma, sorry, underscore cannot be used, right? If I only want only one here, I can just say I only want transform the employee objects to an age object. I can use it. I only want to get the city.
But how come it works here, underscore?
No, underscore is the input parameter, is a placeholder for the input parameter. I mean, as I said
Okay.
earlier,
Each element will be assigned to underscore, and we are accessing the member from that.
correct. I mean, it depends on where the underscore is being used. There are multiple contexts in which underscore is being used. Underscore is being used as an input parameter placeholder. Underscore is being used for a tuple, access the element of a tuple. Underscore is being used to as a default case. Such kind of a multiple. So you will get to understand. I mean, more and more you uh, write code using shortcuts.
The underscore is little confusing, the usage of it.
Yeah, I mean, it takes a bit time. Based on how much examples you try out. Once you try out more and more example, you will clearly get the difference there. We could have used, I think I simply made a complex thing. We could have used filter take each element e dot age is equal to 24 or e dot age is equal to 50 something. That's right. Filter take each element. Filter takes each element. Each element we can use in this fashion. We can just, this is our logic. If this condition holds good, it will return true, otherwise it will return false. Hence we got only records whose age was 24 or whose age was 50. We can get in this fashion also. So that's, I mean, the reason this and this are both same, almost same. We are just using a matching here, pattern matching. We are just using a match expression. Now this works because this pattern matching works because employee is a case class. Employee is a case class. So if I remove that case class, I will define it as a normal class. I will not define it as a case class. Now I will define it as a normal class. When I define it as a normal class, you first of all cannot access these members. So I have to say, now I have to say employee 1, I cannot create a, sorry, this is employee 1. I need to use the new keyword here because it is just simple class. So also you can see that it displays the object in some form because toString method is not defined by the compiler. Similarly, if I say employee 2, the new.
So we have to override all the methods, right? ToString, hash code.
Right. So those things are already done by the compiler if you use case class.
Okay.
Again, while employee 3, I have to say new again. I have to say, again I have to say new. Now if I have already defined that function, right? Get certain. This method I will define. So I will define this function once again. Since employee value not found, so it does not even recognizes this employee because it's now not a case class. I mean, there is some way I need to, why it does not recognize. I mean, somehow it is related to not defining as a case class, but I'm not sure how it is. it should a new keyword. You cannot have a, I mean, you cannot have a, here we need to specify the class itself. We need to specify the class. So the so instead of that simple, I will take the simple one, case character, case character. I mean, we are not defining it as a case class now. We are defining it as a simple class. So what will happen here is, well, Joker, again I have to use the new keyword. Well, Batman, I have to use the new keyword. And also you will see that the display is something different. Now again I can say val message is equal to some Batman match. I'll say case character, and I will say here X. I'll just return X. I will not write anything much here. Case character, I will say Joker, bind value to Y, then return. So as you can see here, this time we are getting an error. Object character is not a case class constructor, nor does it have any unapply method. It does not have any unapply method. So that makes clear that the pattern matching works on complex types like class because of unapply method. It works only because of the unapply method and not because of anything else. So when you define a class as a case class, the compiler automatically defines an unapply method. Because of this pattern matching works. Now here it is not working because we did not define our class as a case class, hence there was no unapply method, hence nothing works. This error you will get. This error is because of that. So mainly the use of case class is to represent each record of a class. Most of the time we use a case class to represent each record of a data. You want to represent like in some Java they say POJO objects. POJO objects they say in a similar fashion. The use case of a case class is to represent each record to a data, each record in the database or a data set. That's the main use of the case class. You will see something employee record you have. Each employee record can be represented as a case class. That's the main use of a case class. Not to go more into that, we can, on an overview, what you can think is case class is used to represent a record. Used to represent. So I went into more of a case class. I think most of them may not be required. It is just for understanding purpose. Most of the time we will treat it as just to represent a record. That's all. So we are left with traits. I think I did not cover traits
So,
and implicit.
do you have any nested classes here in Scala?
Right. You can define a class inside a class. That is fine.
Is that similar to Java nested?
Yeah, it is similar to Java nested. We can have such things. We can always have such things. Mainly such things are used to design factory kind of a pattern. So you will have like class animal, just for understanding purpose. It takes a name. So here you will have class dog class. You can have cat class. So something like this. So you can also have define an apply method here. Apply method which takes the name, and it says if name is equal to dog, return an object of this class. If it is dog, return new dog. If it is a cat, return new cat. So the idea will be we will just create animal. We just specify dog, you will get a dog object. If I specify animal as cat, you will get a cat object.
So this nested class is like inner class, right?
Inner class. Mainly sometimes we use it for factory design pattern. From the same animal factory, we are getting different dog object, we are getting cat object, just by specifying a different parameter. So tomorrow and day after tomorrow we should get finished the traits and implicit. After that we shall start with Spark.
I have few questions. I'll ask on the end, Pramod.
Right. But today I may not be uh, available because I have to.
Okay.
I have a corporate training, so till 6 o'clock I will not be available.
Okay, I'll send out a mail.
Yeah. Please do send a mail. I will try to answer this.
Okay.
So we'll wind up the session here, and let's continue tomorrow on traits. We'll continue on traits tomorrow. Thanks everybody, and let's meet tomorrow. Good night and have a nice day.
Thank you.
Thank you.
Thank you.